Okay. Now, before Christmas break, we did this lab on that Wednesday and Thursday before break, remember? And what we learned was if we drag this point P that is on this vertical line, and we drag it across this function, what do we notice about it? How many times does that point P intersect that function graph? 1 time. Now, look at the non-function down here. If I'm looking at the non-function and I take the point P and drag it, how many times does it cross it?
3 or 2. Or 1.
It crosses at 1 or 2 or 3 times. Do we all understand that, yes or no?
No.
Now, so what you're telling me is what would be the general rule here if I'm looking at a function graphically?
Non-functions have the same x value with multiple y values. Non-functions not only have one.
No.
Vertex.
No.
Okay. Non-functions.
If you have a vertical line, if you have a vertical line and you draw it down any function graph, how many times will it cross it? Once. If you draw a vertical line down any non-function graph, how many times is it going to cross? Probably more than 1 time. At least more than 1 time, because that's what makes it a non-function. Do we understand that? Okay? So, with that said, the vertical line test that you all are going to be talking about, right here, draw any line anywhere on the graph. If it crosses the graph in more than 1 spot, then it is not going to be a function. Do we understand that? For example, let me pass these notes out to you guys so you have them. I'm going to be doing these notes a little bit out of order, so you need to get the back side of the notes. So, if I have this graph right here, is this going to be a function or a non-function? So let's go ahead and start drawing a line. How many times is it crossing? Crossing 1 time. Do we see that? So is this a function, yes or no?
Yes.
Yes, this is a function. Well, how about this one? Is that going to be a function?
Yes. Yeah.
Look how many times I can draw a vertical line and it still only crosses it once. So yes, this is a function. Well, how about this one? Is that going to be? Well, clearly no, because look, it crosses in 2 different spots. So no, this is not a function. Do we understand the vertical line test? Yes or no?
Yeah. Go ahead.
So now, all this is telling you graphically if something's a function or if it's not a function. Now, let's go back to our lovely little graph, our lab that we did last week before, and let's go to the table of values. Now, what happens whenever I give you a table of values? Is this a function versus not a function? Compare the two. If you're a function, look at that table of values compared to a non-function. What did we come up with before we left for break?
Well, then every x value is 1 value.
For a function, for every x value, there's exactly 1 y value, whereas a non-function, for every x value, there can be more than 1 y value. Do we understand that? In other words, I refer to those as double dippers. What do I mean about a double dipper? It's 1 chip, and how many times has it gone into the dip?
More than once.
More than once. In other words, I have this 0 here, and it's gone to the value 2, and it's gone to the value -1. Is that legal? No, but that's what makes it a double dipper. Do we understand that, yes or no? Okay, well now let's go back to our lovely little notes, and we're going to go all the way to the top. And chapter 2-1 is where we're at. Notice we've been jumping and hopping about here. A relation is a set of pairs of input and output values. What's an input value? It's the x value. What's an output value? It's the y value. We understand that? It's very simple. We're not going to worry about this too much here. You can look at these in several different ways. The first way that you can look at input and output values is going to be by ordered pairs. Another way is called a mapping diagram. A mapping diagram uses arrows. It says -3 goes to the value 4. In other words, you have the point -3, 4. Another one is going to be 3 chose -1. Then we have 4 choosing -1 and 4 choosing 3. So we have 2 ordered pairs going off of the value 4. 4 -1 and 4 +3. You understand that? That is a mapping diagram. The next one's going to be an XY table, meaning input and XY, input and output values. And the last one is graphically looking at this on the coordinate plane. Do we all understand the 4 ways that you can see these things? Now, domain. All domain is all the set of x values in a relation. It's the set of all the x values in a relation. Which means if that is the x values as your domain, what would y be then? Your range. So if you're looking at domain, immediately your brain should say x. If I say range, immediately your brain should say y. So if I say x, what is x? Domain. What is range?
Y.
What is x?
Range.
What is y?
Range.
Y'all understand that? Okay, good. Because now what we're going to do is we're going to simply identify the domain and the range of this relation. So tell me, what is the domain? Please stating it in chronological order from least to greatest. So what's the domain here? -6, -2, 1, 3, 7. Does everybody see that? Yes or no? All I did is I took the x coordinates and put them in numerical order. What's my range?
-3, 1, 4, 6.
Got that written down.
Very good. Do we understand the range? Again, domain is? Range is? Do we understand that? Now let's say I had a repeated x in there. I had the .41 and the .43. Would I need to repeat 4 twice in my domain? No, I would not. So I do not need to repeat my domain or my range if they're repeated values. Now the next thing is talking about a function. I'm going to make this very clear. I've written it down there several different ways for you, but here's the whole kit and caboodle. Are you listening? To be a function, every x must choose only one y. To be a function, every x should choose only one y. If the x chooses more than one y, it's not a function. Now, I refer to this as the ice cream candy example. You guys are my class, 9th period class. You guys represent my x values. You are my input. Do we understand that? To be a function, you all must vote today. I'm going to give you 2 options. I'm either going to give you the ice cream option or I'm going to give you a candy option. Anyone here wants ice cream, please raise your hand. Put your hands down. Anyone here wants candy? Please raise your hand. Now, since everybody voted, we are a function because nobody chose both ice cream and candy. Does that make sense? Because you're not a double dipper. You with me? Now, how many people in here want both ice cream and candy? We are no longer a function because we're greedy little people. We understand that. Okay? You good? Now, the other concept is dipping your chip into your salsa or into your chip dip. You cannot dip the same chip into your salsa or chip dip that you share with everybody else more than one time. If you do, then you're no longer a function. Do we understand that, yes or no? Okay. Now, with that said, there is going to be one question you have to ask yourself to determine if you are going to be a function. And that is did your x value repeat? In other words, did Tristan, who is my x value, repeat and choose both ice cream and candy? If he chose both ice cream and candy, then he is no longer allowing our relation to be a function because he's greedy and chose both ice cream and candy. Do we understand that? So we need to ask ourselves, did our x values repeat? If our x values repeated, then it's not a function. But if they did not repeat, then it is a function. Now, you need to be very, very careful. Because would Mrs. Yoder possibly put someone in there like Trevor, who has the same chip or the same ice cream but went back for seconds? Is that legal? He still chose ice cream, but he wanted more. He didn't change his mind and ask for candy, did he? So would he still be considered a function if he went back for seconds for the same thing that he chose? Yes, because it's the same point, right? It's the same ordered pair. Do we understand that? So whenever you ask yourself if the y value, if the x value repeats, you need to say, okay, did it go to the same y value? If it went to the same y value, then it's still a function. But if it went to a different y value, then that means it chose two things. Now we're allowed to choose two things.
What would a graph like that look like?
It would have another spot. Think of it as data.
Okay.
Okay. Okay, tell me, is this a function? So this is a mapping diagram, and we're going to look at this and say -3 chose -2, 0 chose 7, 4 chose 1. Did I repeat any of my x values and have two different y values? No. So is this a function? Yes. Is this one a function? What am I looking at, x or y? X. So let's read off our x's. 4, 8, 1, 6, 4. Did I repeat any x's?
Yeah.
Yes. What is my culprit here? The 4s are being mean. They are double dippers. They're choosing both ice cream and candy. Is that legal?
No.
No. So therefore, this is not a function. Do we understand that? Is this a function?
No.
Why no? 2 has chosen to go to -3 and go to +3. Is that legal? No, it's not. So therefore, this is not a function. Is this a function? What do I look at?
Yes.
What do I look at? X. So read off your x's.
-7, 9, 14, 7.
-7, 9, 14, 7. Did we repeat any of them?
No.
Is it a function? Yes, it is. Do we understand that? Now, with that said, I'm now going to pass out to you a little homework, and we're going to start that so you have a clue what you're doing. Like I said to you before, today we have a lot to cover, but it's all about you guys working more independently by yourself the remainder of the period. Okay? Well, with the partners. So, yes.
Does it matter if the output's repeated?
Tell me this. Whenever I asked for ice cream and candy, was there a lot of people who chose ice cream? Was the output repeated whenever you guys chose ice cream? Was that legal? Think of it this way of driving on the road also. There's lots of people who choose to drive 77 north. Are we a function? Yes, because we chose one road. You can't drive on two roads at the same time. Come on. Come on. Okay, so if we're looking at tonight's homework, number 1, it says, given each set of ordered pairs, identify the domain and the range. So what's the domain for number 1?
0, 0, 1,
The x's are 3, 4, 0, 4, and 3. So what's my domain?
0, 1, 3, 3, 4.
0, 3, and 4. I do not need to repeat the 3 and the 4, even though it was a repeated value. Do we understand that? What is my range?
-2, 1, 2, 4.
Notice how we put them in numerical order. Okay, the next set of instructions say determine whether each relation is a function and explain why it is not a function. It's not. So number 3, is this a function? What do I look at whenever I have a relation with ordered pairs? The domain, which is the x value. 0, 1, 2, 3, 4. Did I repeat myself?
No.
Am I a function?
Yep.
Yes, I am. Number 5. Number 5 is directly below it. So now let's look at those x values. 1, 3, 5, 1, 6. Did I repeat any?
Yes.
Yes. So am I a function? No, I am not. Why? And tell me mathematically.
The y values aren't the same.
Keep going.
X.
The x value 1 chose 2 different what? Y values. That's why it's not a function, because the x value, 1, chose 2 different y values. Number 9. Is this a function?
Yes.
Why is that a function when I'm giving it in a mapping diagram? How do I determine that? There's not 2 arrows coming off of any one x, so therefore, yes, this is a function. How about number 10? Is that a function? No. Why is number 10 not a function?
2, 3, 4.
The x value, 2, chose 2 different y values. Turn it over. On the back, it says use a vertical line test. Everybody turn the paper over, please. I want you with me. I understand this is a relatively easy assignment. However, I want you with me. Use the vertical line test to determine whether each graph represents a function. Be sure you draw the line to show why. You circle yes or no. So number 12, is this going to be a function? Draw a vertical line and see how many times it intersects.
Yes.
Yes. How about number 13? Is that a function?
Yes.
Yes. How about number 14?
No.
No. Are we understanding our homework tonight?
Yes.
Okay, put this away for now. Now, do you remember who your partner was from before break?
Yes.
That's right. Okay. Now, what I want you all to do is partner up. I'm going to send you a document. That document is going to be called Domain and Range.
Same partners.
Same partners as you had before? Who was not here today?
Carly.
Kanan. Lance. Brendan.
Carly.
Abby.
Scott.
Where is Scott at?
Right there.
Okay. You all get this document? I missed someone. Brandon, log in. Okay. Now I'm going to pass out to your lab. Someone here does not have a partner. Please stand if you do not have a partner. Okay. Dylan, Heidi, Justin, Kyle.
I'll go there.
Yeah.
Okay, get busy on this lab. The rest of the period is yours to work on the lab and to work on. Does everybody have a lab? Okay, the rest of the period is yours. You have today and tomorrow to finish that lab.